Hello and welcome to video 6.1. In this video, we are going to be looking at how we can use ratios to compare two quantities. Well, let's jump in and just talk about what is a ratio. A ratio is a comparison of two quantities. It shows how many times as great one quantity is than another. A ratio can compare a part to a part to a whole, or a whole to a part, and we're going to talk a little more about that throughout this video. And when writing a ratio, the order does matter, and we'll talk more about that as well. You'll see that you can write a ratio in three different ways. You can write a ratio using a colon, so if we were to say a ratio of 4 to 1, you could write 4 colon 1. You can use the word 2, so you could say it's a ratio of 4 to 1. You can also write it as a fraction of 4 over 1. Most commonly, you'll see it written as a fraction, particularly in math examples. When you're solving things, you'll tend to write it as a fraction in order to find equivalent ratios. But you'll see this written in all three different ways. Okay, let's look at our first example. Here's a picture of 3 stars and 1 moon. So the ratio of star-shaped beads to moon-shaped beads in a bracelet is blank to blank. Well, since they started out with saying star-shaped beads first, we actually write that number first. And I notice there are 3 star-shaped beads and there are 1 moon-shaped beads. So we could say that the ratio of star-shaped beads to moon-shaped beads is 3 to 1. And remember, we can write that as 3 colon 1 or as a fraction of 3 over 1. So let's look at A. Write the ratio of moon beads to star beads. And since they said moon first, we're going to write the number that associates with moon first. So we know that's 1. And the star beads we know is 3. So I can write that ratio as 1 to 3. I could write it as 1, 2, 3. And I can write it as a fraction of 1 over 3. Let's look at D. Write the ratio of moon beads to all beads. So this is a little different. So they said moon beads first. So I know there's only 1 to all beads. Well, we have 1, 2, 3. We have 4 in total. So I know that's a relationship of 1 to 4. And then in C, we have if the bracelet has 2 moon beads, how many star beads does it have? Well, wait a minute. I tend to think of ratios as rules. And the rule here is that for every 1 moon bead, there's going to be 3 blue stars. So if we add a second moon, how many stars do we have to add? Another 3. So if there's 2 moons on the bracelet, how many stars? There would be 1, 2, 3, 4, 5. There would be 6. And don't you notice that a ratio of 2 moons to 6 stars is equivalent to saying 1 moon to 3 stars? Isn't 2/6 equivalent to 1/3? So our relationships with fractions and our knowledge of fractions is going to be very important when finding equivalent ratios. Okay, let's look at the last one. If the bracelet has 9 star beads, how many moon beads does it have? Well, I don't even have to draw the picture if I don't want to, because I could say that for every 1 moon, there are 3 stars. And I can label this as moon to star. Now they're saying if I have 9 star beads. So if I wanted to make this equivalent, I could say, well, what out of 9 is equal to 1 moon for every 3 star? Well, I'm basically having 3 times as many star beads. So if I have 3 times as many star beads, I'm going to have 3 times as many moon beads. So I will have 3 moons for every 9 stars. Now we just dove a little bit into equivalent ratios and using our knowledge of equivalent fractions to help us find equivalent ratios. So think about those moon and star beads when these next couple of questions come up. Essentially, equivalent ratios are ratios that name the same comparison. You can find equivalent ratios by multiplying or dividing both terms of the ratio by the same number. And that's what you learned about finding equivalent fractions. So multiplying the numerator and the denominator will keep it in proportion. So think about the moon and the stars. The rule is for every one moon, there's 3 stars. That's the rule. Every time you add another moon, you've got to add 3 stars. So here I could say 2/7 is equal to 4/14 because I'm essentially multiplying both the numerator and the denominator by 2. And then 8/24 is equivalent to 2/6 because I divided the numerator and the denominator each by 4/4. Now, to bring back some of the properties we've learned about, this is essentially doing 2/2. And a fraction 2/2 is equal to 1 whole. So we're multiplying 2/7 by 1, and that's the identity property. That's why 2/7 is equivalent to 4/14. It's just we're getting larger in our proportion. You know, if you had a relationship of 2 to 7, it's the same as 4 to 14 because of that rule 2 to 7. Okay, we're going to look at this first question together, and you're going to do the next question on your own. The ratio of green apples to red apples in a bowl is 3 to 5. So when they say green apples first, the first number is associated with green. So if we're comparing green to red, and I like to write it as a fraction, green will be 3 because that was the number said first, and red, which is the color said second, we use the second number of 5. So green to red is 3 to 5. If there are 20 red, so I'm going to make an equivalent fraction, and if red is in the denominator, I'm going to put the 20 in the denominator. I need to see, well, how many green will there be? We can give this a variable of x. So 3 out of 5 is equivalent to what out of 20? Well, if I did 3 to 5, and I did another set of 3 to 5, and I did another set of 3 to 5, how many sets would I be making to get to 20 red? It would be 4 because 5 times 4 is 20. And I'd also have 4 sets of the 3 green in my group. So 3 times 4 is 12. Very good. So I would have 12 green apples. Well, that's the first part of this question. The second part of the question is how many total apples are there? Well, there's 8 total apples in our first ratio. And when we figure out that there are 12 green and there are 20 red, altogether that makes 32. And look at that. 32 is 4 times 8. And we noticed that we had 4 times as many of the red and green apples. So your total is also 4 times the original total. Alrighty, I want you to press pause. I want you to solve this question on scrap paper and then press play to see if your answer matches the correct one. See you in a bit. Alrighty, so did you set it up like this? I noticed that this question asks about how many texts did Lucas's sister send if Lucas sent 42 text messages? Well, the original ratio of number of text messages sent by Lucas to the number of text messages sent by his sister is 7 to 5. So I wrote the 7 correlated to Lucas and 5 was the sister. And then when they said that Lucas sent 42 total messages, I knew to put 42 in the numerator where Lucas is. So let's figure this out. How many times 7 gets me to 42? I know that's times 6. So 5 times 6 is 30. So 30 text messages were sent by Lucas's sister if he sent 42. I hope this video helped you learn a little bit about ratios and how to find equivalent ratios. You can watch this video anytime in Lesson 6.1 or whenever you need a refresher. Thanks for watching.